When you look at NASA's James Webb Space Telescope, you can't help but see the huge gold mirrors. But that gold is really only on the surface. The rest of the mirrors are made out of a metal called beryllium. Let's head over to the shop that worked on these mirrors to get a better idea about why this metal is so remarkable. And it's like, follow the noises. Engineers chose beryllium for 3 major reasons. It is super lightweight. It is the second lightest of all the metals and only 2/3 the weight of aluminum. It's super strong. Beryllium is 6 times stiffer than steel. Each of these cantilevered weights are the same except for the type of metal. They are the same length, the same weight, and size. Look at what happens when they are lifted and released at the same time. That beryllium wiggles with less intensity and stops moving first. That's because it's far stiffer than the other two. So it can also hold its shape over a really broad range of temperatures, and that's especially important in the cold ones. I measured these identical aluminum and beryllium mirrors, and then left them in some dry ice for a while. Science. I do have to admit that my measuring technique could use a little work, but the aluminum shrunk more than the beryllium. Materials as a whole tend to change in shape, volume, and density in response to temperature. When something is heated up, the molecules begin to vibrate and separate a little. The amount that the material changes is predictable and is based on its coefficient of thermal expansion. So beryllium, it stops shrinking and changing its size when it cools below 100 Kelvin. So the mirrors we see are a little too large on Earth, and will be the exact size they need to be once they are out in space. Beryllium is obviously an incredible material, but everything does have its nuances. So, why isn't beryllium used more often?
Machining beryllium requires extreme care. And if you think about it, beryllium actually is a powder that is pressed together and requires very, very light cuts. Any small mistake, it would crack, and there would probably be a piece that would chip off. And you've lost a part that could be worth anywhere between $1,800 to $2,000 a pound.
Under the wrong circumstances, beryllium may be fragile, and it's fairly expensive. But it holds its shape well, is very stiff, and most importantly, it's lightweight. Rockets need a lot of fuel for each pound of payload. So any weight-saving measures are really, really worth it.